going to be talking about parametric equations. These do sort of go with what we're talking about because parametric equations, normally when we do equations, yeah, let's all put our phones away. Parametric equations have to do with, instead of using an x and a y, it typically uses a t and sometimes a theta. In other words, it's using some other variable in place of that links your x and your y together. Normally when we graph something, guys, we graph it as y here and x here. Well, when we're doing a parametric equation, we're splitting the x and the y into two separate graphs. And the thing that matches them up is time. Okay? This is an easy thing if you're in physics because we often talk about how far something goes horizontally and how far something goes vertically over time. If you throw a ball through the air, it does a certain amount of this, but it also does a certain amount of up and down too, doesn't it? It does them both simultaneously, but we can treat them separately. The thing they both have in common is all of that's happening over a certain amount of time. So we're going to go from this to splitting it into x over time and y over time, okay? A horizontal distance and a vertical distance. So we're going to take one graph pretty much, or one equation, and turn it into two equations where the common link is time, okay? So let's look at this. And you can see how this kind of works because instead of talking about x and y, we've linked x and y through r and theta up to this point, haven't we? So you can see how this kind of fits here as well as it fits anywhere. All right, so let's look at an example here. It says a baseball is thrown in the air. The function f of t equals 40t represents the horizontal distance the ball has traveled after t seconds. And the function g, which is g of t, which is negative 16t squared plus 48t plus 64, represents the vertical height of the ball after t seconds. So what we're getting is we're getting the x value here, we're getting the x here, and we're getting the y here, aren't we? So the horizontal distance would be like x, how x changes over time, and the vertical would be how y changes over time. Now notice the y actually looks like the graph of the ball, doesn't it? If you throw a ball in the air, it makes sort of a parabolic loop, doesn't it? So the y tells us what's happening. The x looks very different. Okay? Now, to show both the vertical and the height and the horizontal distance on the same graph, we use parametric equations. Okay? So the parametric equations we define x as our f of t and y as our g of t. Now, why did we do that? Because look what we did. We said this was our x and this was our y, didn't we? Guys, when we do this, t, right here, t is called the parameter. The interval at which we measure t, say we're only measuring it over the first 4 seconds, that interval from 0 to 4 would be what we call L. It's the parameter interval, okay? So we've got a parametric interval, we've got a parameter that we're actually defining, the thing that links the two together. So is everybody following this? The parameter is what variable links x and y. The parameter interval is the interval over which we're measuring. And then we get this guy, which is a parametric curve. So how do we get the parametric curve? Well, we find t, we pick t and we plug it into x and we plug it into y, and then we can, once we have x and y separately, guess what we can do? we can graph them like we normally would on an x, y coordinate plane. Does that make sense? So what is our time interval? Seconds, yep. And we wanted to know for the first, well, I don't know, we could take this for the first 4 seconds if we wanted to. How long? After t seconds. So let's do the first 4 seconds. That would mean t was 0, 1, 2, 3, and 4. So this would be our parameter interval would be t was between 0 and 4. We have an x that's 40t. Now where that's coming from is the equation we had up here, right? X was 40t, and then y was that other equation. Negative 16t squared plus 48t plus 64. Now, cool thing is that you don't have to do a whole lot of plugging and chugging here. All you have to do is get your calculator out and plug in one of these equations for y sub 1 and one of these equations for y sub 2. Okay? As a matter of fact, there's something even easier. There's an easier way to do this. You want to know an easier way to do it? Yes, no?
Yes.
Okay, hit your mode button. Hit your mode button. Go down to the fifth line that says function. What word do you see right next to function? Parametric. So arrow over to parametric and hit enter. Okay, now hit second mode, which will quit out of that. Now I want you to hit your y equals button. Do you see that every one of those has an x and a y of t? So for x of t, we're going to put in 40t. And if you hit the button that you normally do for x, guess what it gives you as your variable?
A T.
T. And then arrow down and put the other one in for your y.
This is so cool.
Now, once you get those in, I want you to hit second window, because now it's going to let you set your table up. We wanted to go from 0 to 4, didn't we? So table start is going to be 0, and our table is going to change by 1, isn't it?
Yes.
So 0, 1, and you can hit second quit. Did everybody go to table set and change it to 0, 1? Okay, now hit second graph, and it will give you the table. Look at that. So t, when t is 0, x is 0, and y is? And then 40, 96 is handy, isn't it?
What did you put? Why did you put?
Because I want the food option.
Why did you put 0?
No, go ahead.
Why did you put 0?
Did you find that? Those values? Those are what's on your table, isn't it?
Yes.
Now, here's the cool thing. We can plot all those points, can't we? Let's plot all those points. Let's go by, what, tens?
Yes.
So 20, 40, 60, 80, 120, 140, 160. Okay. Same here. 20, 40, 60, 80, 120, 140, 160. Okay. So let's graph. 0, 64. It's about there.
What did you have by 10?
I went by tens, but then I marked by 20s.
OMG.
So graph these. So this is t equals 0. This is at t equals 0, right? Now we need to be able to mark which direction we're going because time flows only one direction, doesn't it? So we're going to put an arrow on this showing what direction we're going. So at 40, then we do 40, 96. So 40, 96 would be about here. And then we're going to go to 80, 96. So it's about here. So somewhere in between there it went up, didn't it? And hit its peak. 120, 64. And then 160, 0. So do you see what's happening here? It's going to go up and back, down again, isn't it? Okay. So this is t equals 1. This is t equals 2. T equals 4. So in other words, we would draw our arrows going this way, wouldn't we? Now, to double check and make sure we actually got this graph correct, I would like you to hit second quit out of your table mode and then just hit your graph button. Hang on.
Mine doesn't do anything.
Hang on.
Oh, there it is now, dude.
Oh,
Second
please don't.
format. Oh, you need polar. Go to second and hit zoom. Second zoom.
Hold on. Oh.
Oh no, we want it rectangular.
She's still not sure.
Hang on.
Mine worked.
Let's just do Zoom.
See?
Graph.
Oops.
Okay, how about you do this?
If you're not seeing anything, it's because your window's too small. Hit window. T minimum should be what? What's our lowest T?
0.
0. So I'm going to go to -1. T max is what? 4, right?
What's going on? Yeah.
Okay, so set your T min at 0. We're adjusting our windows so we can see it. T max is 4. Went by 1. X min. Our minimum X was what? 0? Our maximum X was 160. Our X minimum, our Y minimum was 0. And our Y maximum was what? Probably 160, yeah. All right, now hit graph. And look, you get the graph, don't you? Okay, so if you don't get the graph, you can always readjust it so that you get the graph. Hitting window, right?
Oh, just kidding. That first problem was fantastic. It was fun on the first problem.
It'll still be fun. Because the nice thing is you can still continue to use you can still continue to use your calculator to get the table, can't you?
Yes.
All right. Everybody good?
Not right now.
You sure? Okay. So let's go to our next.
I just don't know how to use calculator.
Don't know how to do what?
Work the calculator.
Oh, do you need some help?
I'm not.
Okay, so let's go, and I'll put this one actually on the demo calculator for you, okay? So we're going to go back to our calculator, right? We got to set this up. We know we're going to be doing our first column is T, the second one is X, and the third one is Y, isn't it? Now, where do my T's start and end? Look what they've given me right here. So what do my T's need to go? -4 all the way to 4. So -4, -3, -2, -1, 0, 1, 2, 3, and 4. And that's okay because now we can go back into your Y equals, And clear those two out and put your new ones in. T squared minus 7, and then
Right.
I'm just now making the chart, please. Okay, what did you say? Do you want to calculate?
okay. So let's go over.
These fractions, do we need to keep them as fractions?
I'm just putting them as decimals because you're graphing them. Now we're going to graph this guy. I would assume we graph this by 1 since we're going all the way from 1 to -4 to 4, right? So this is x and this is y, and our x's go from -7 to 9. Yeah, I'm going to go by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Just go by ones. So let's graph this guy. 9, 3. So 9, 3. 2, 3.5. Now, I'm going to start going this way and connecting it as I go because remember, I have to draw arrows indicating which direction it's going, don't I? Make sense? We don't go past it. Just put it in and then double check your graph on your graphing calculator by setting up your window to match your parameters. Now you know why things are called parameters, don't you? It's the window in which you're looking at it. Those are your parameters. So we need to set up our window to match that. So that's all we're going to do. We know how to use our calculators to do that. Let's go. Parametric equations in rectangular form. So how do we write a parametric equation in rectangular form? You have to eliminate the parameter t. Guys, this is the whole thing. Eliminate the parameter. How do we do that? We plug from one into the other, don't we? So we solve one of them for t, and then we sub in to the other one. So let's do that. So which one of these you want to solve for t, the x or the y? Okay. Now, I would normally pick the x. You want to know why? Because how do we usually like all our equations to look? Y equals something. So let's solve this guy for t. Because then once we plug in, we'll have y equals, won't we? So x equals 4t minus 1. So we need to solve for t. So what are we going to do first? Add 1 to the other side. So we get x plus 1 equals. And now we're going to do what? How do we get t by itself, guys? Divide by 4. So we have t is x plus 1 over 4. So we are now going to take this. That was step 1. So this was step 1. And now we're going to take this, and step 2 says plug it in right there. Plug in. So let's do that. So y equals 6 minus what? Now, if you're smart, I would go ahead and multiply everything through by the denominator, common denominator, and then you can redivide at the end. But it makes it easier when it's not all fractions, doesn't it? So what is my common denominator? So I'm going to multiply this by 4, and this by 4, and this by 4. That goes away. So now 4y equals 24 minus what? Be careful. That x plus 1 is in parentheses, isn't it? So guess what needs to be multiplied by both of them? That negative. So it's minus x minus 1. So now we end up with 4y equals negative x plus what? And why did I put it negative x there? Because what do we normally put first? The x's and then the... So now all we have to do is divide everything through by what?
4.
So we divide through by 4, divide by 4, and divide by 4. And we get y equals negative 1/4 x plus 23 over 4. Now, the cool thing is that we know what this is, don't we? This is the equation of a what? This is a line, isn't it? So this is a line. So if it is a line, does it have any domain restrictions? No, it doesn't, does it? So its domain is going to be all real numbers, isn't it? Since it's a line, it's a diagonal line. Now, if it were a vertical line, it would definitely have a domain restriction, wouldn't it? But this one doesn't. Okay. Okay. So here we go. Let's try another one. Let's try a few more of these until we get it down. So which one do we prefer to solve for? Okay, so let's do x. We have x equals t squared plus 5. What's my first step? Subtract 5. So now we have x minus 5 equals t squared. So now what? Square root. So t equals the square root of x minus 5. And we're going to take that and do what with it? Plug it into the other one. So y equals 3 times the square root of x minus 5. All right, this one does have a domain restriction. As a matter of fact, when we took the square root, since we were solving, what should we have thrown in front of that square root symbol? Plus or minus, right? Plus or minus. So this becomes plus or minus, doesn't it? What is the domain restriction here?
Is it a hole?
Does it have a hole?
I don't know. I just know.
Here's the cool thing. If neither one of them have, how can I say this? The only time you have a domain restriction is if you've got a restriction on t. Did it give us a specific set of t's? Did not, did it? So we don't have any domain restrictions until we get down to what? this would be a domain restriction that we would have to fix. This is a domain restriction for t, so we would have to interpret that for x. So how would we change that to x for a domain restriction? Plug your t's into your x equation. Really? That's as hard as it is. So if we took 2 and plugged it in right here, half of 2 is what? 1. Minus 3 is? So this goes from -2, greater than or equal to x, less than or equal to, and then we're going to take 8 and do the same thing. What's half of 8? Minus 3 is 1. That is our domain restriction. Everybody get how we find the domain restriction? You take the t's and plug them into the x function. Everything else works exactly the same. So what I would like for you to do is try this one right here. Solve for x, or solve for t. Use this and solve for t, and then plug it into your y function, okay? And see if you can do this. Sub it into the y. Well, you're going to add 3 to both sides, right? So you get x plus 3 equals 1/2 t. How do you get rid of the 1/2? So times 2, and then this whole thing is times 2, right? So t is going to be equal to 2x plus, so we take this and plug it in right there. Now you do have to multiply it out. Y equals 2x plus 6 squared minus 7. So what is 2x plus 6 squared? And then minus, and that's equal to y. So 4x squared, so y is 4x squared plus 24x plus 29. And that would be your answer with your domain restriction. How are we feeling about this? Pretty good? Okay. I want to do 2 more examples where we have domain restrictions that don't really look like domain restrictions, but are there. They're implied. Okay? We've got obvious ones here, don't we? So let's look at what's an implied one. Can anybody tell me why we have an implied domain restriction on number 7?
Because there's T's in the denominator.
Yes, very smart. There are t's in the denominator, aren't there? As a matter of fact, there's a plain old t in the denominator, so What's the only thing t can't be? You got t's down here. What can you not divide by? So t obviously cannot be 0, which means x cannot be what? If we plug a 0, see this one's hard. If we plug a 0 in right there, what happens? It's undefined too, isn't it? Oh, that's a little freaky, isn't it? So how do we figure this out? Do you know what we have to do? We can't just, our normal thing is to plug in, right? We can't do this because it's undefined. So what we have to do is this. Let's go ahead and solve for t like we normally would, right? Solve for t. So how do we solve for t in this? We're going to have to cross multiply, aren't we? Boom, cross multiply. xt is equal to what? Now we got to get that t separated somehow. So we have to get all of our t's to what? One side. So what would my next step be here? Subtract by t. xt minus t equals 2. So now what? How do I get t separated? Nope. Both of those terms have a t in them. Factor a t out. If t comes the outside, what's left on the inside after we factor it out? Okay. Now we can divide and get t by itself, can't we?
Yes.
So t is going to be equal to what? So since we couldn't plug in before, what we have to do now is see what's going to make it undefined now. What will x be that makes this undefined? So that's how we do it when plugging in t0 won't work. So this is where we find out. Now, we still have to finish this up and take this and plug it in where? Yep, so let's plug in. And we get y equals 1 divided by, why am I writing it sideways? Because it's simpler. It would be the same as 1 times what? Yeah, we just flip, right? Flip it over. So 1 times that, so what is my final equation? Y equals what? X minus 1 over 2, where x cannot be 1, right? All right, let's try one more. And then we'll move on to the last chunk of this and be finished. What is the implied domain restriction on t here? What can t not be? And why is there a domain restriction on t? Anybody remember from the very beginnings of this class? Right here. We cannot take the square root of a negative, can we? Which means that everything underneath that square root has to be greater than or equal to what? 0. So we have an implied domain restriction here. We have to come over here and say t minus 3 has to be greater than or equal to 0, doesn't it? Which means what? T has to be greater than or equal to 3. Now, we're going to try this and see, can we plug it in? Yeah, we can plug this one in, can't we? Can't we take this and plug it right back in up there for our domain restriction? So if we plug that in, x can't be square root of what? 3 minus 3 plus 5. That goes to 0. Now it says t greater than or equal to 3. So if we put anything bigger than 3 in, isn't it going to give us a value that's bigger than 5? Does everybody follow that? If this is more than one number, then this has to be more than one number. This is just the border, isn't it? So if anything bigger than 3, plug it in. Think about what would happen. If you plug 4 in here, you'd get 1 plus 5, wouldn't you?
Yes.
So that'd be bigger. So anything bigger than 3 here gives you something here that's bigger than 5, doesn't it? So instead of just saying x can't be 5, we need to say x can't be what? Greater than or equal to 5. Okay? So we're going to take this and change it and say, all right, this has to be greater than or equal to 5. Now let's actually solve it. So how do I take, there's my domain restriction. So how do I take x equals the square root of t minus 3 plus 5 and solve it for t? What do I need to do first? Guys, I'm trying to solve for t. What needs to happen first? Subtract 5. So x minus 5 equals the square root of t minus 3. Now what? Square both sides. So square and square. So now we're going to get t minus 3 here, and we're going to get x squared minus 10x plus what? 25. Last thing I need to do? Okay. X squared minus 10x plus 28. So now I'm going to take this and plug it in up here. So let's do that. Y equals 1/2 x squared minus 10x plus 28 plus 8. Now you get two choices here. You can get rid of that, or you can just take half of everything, except for the 8. I'll just go ahead and take half. Let's distribute this in and see what happens. We get 1/2 x squared, right? Minus what? And then plus, and then plus 8, right? So y equals 1/2 x minus 5x plus 22, where x has to be greater than or equal to 5, right? The domain restrictions really aren't that bad. And this is just good algebra practice. All right, last topic of the day, how to go from polar and parametric, how polar and parametric equations are similar. Are they similar? R equals F theta. Okay. R is a function, think about it. Polar equations, R is a function of your theta, isn't it? Your angle? Yeah. So X is going to be F theta cosine theta. And Y is, I bet you can guess what it's going to be. F theta what? Sine theta. Think about why that is. Remember, X was equal to what? R cosine. And Y is equal to R sine. So we've just replaced R with the F theta, haven't we? In other words, whatever's on the other side of the R goes here and here. So we solve for R and plug in. Get it? So if we've already solved for R, it's super easy. So have we solved for R? Look at number 9. So we just have to take this and plug it in there and there, don't we? So X is going to be 3 cosine theta, and Y is going to be 3 sine theta, isn't it? So same thing again. Look at number 10. X is going to be what? Four sine theta, that's our R, right? Our F theta, times, and then Y would be what? Yeah. 4 sine theta times sine theta, which would be sine squared theta, wouldn't it? We're literally just plugging in. Well, what if we already have the X and the Y, and in terms of the parameters, we do this the same way we did for T, except instead of solving for T this time, guess what we're going to solve for? Yeah. Correct. Uh-huh. I'm going to get him in here to yell at you. All right. So we need a strategy here, don't we? We need to get theta on its own, don't we? Actually, cosine theta would be better because whatever's next to cosine theta is our R, isn't it? Or sine theta. Okay, so let's take X equals 3 cosine theta and solve it for cosine theta. How do I solve it for cosine theta? Guys, this is algebra 1. How do you get cosine theta by itself? Thank you. It's not any harder than that. Now let's do Y equals 2 sine theta. Now what do I need to do? Divide by 2, divide by 2. Good. So now we have cosine theta and sine theta. But you know, the cool thing is I don't have to solve for theta because I know a Pythagorean theorem that says this. Identity says this: sine squared plus cosine squared equals. So now all I have to do is find cosine squared. What is cosine squared? If I square both sides of that, what do I get? And if I square sine, what do I get? Y squared over 4. So now if I take my sine squared and add my cosine squared to it, cosine squared plus sine squared is equal to 1, isn't it? So now I can take this and plug it in for that, and this and plug it in for that, can't I? And I get rid of all my thetas and just have x's and y's. So I get x squared over 9 plus y squared over 4 equals 1. Ooh, I know what that's the equation of. What is this equation of? An ellipse. If there was subtraction in between, it'd be a hyperbola. Well, it's not a circle because they're not the same underneath. All right, so now, number 12. You guys try it. Try 12. Yes. You can. It's the same way. You're doing the same thing.
No, they switched them. They put X in the front.
Yes, I can't do that.
It doesn't matter. It's still the same. Hey. Do number 12. Follow the guide of what we did on 11. Are we okay with this? All right, so let's look at a variation on this. Look at x. In number 13, look at x. It's already equal to sine squared, isn't it? So do we have to do anything to it? Nope. It's already sine squared. However, y is not. So we have to say cosine squared is going to be equal to what in this case? Y squared over so sine squared plus cosine squared is equal to 1, right? So sine squared this time is just x. Cosine squared is y squared plus 16 over 16 equals 1. Now, if it's not a circle, this thing only has a y squared and not an x squared, what must it be? A parabola, which means we probably ought to get the y squared on one side by itself and the x stuff on the other side, shouldn't we? Write it like it should be written. We've never written a parabola like that in our lives, have we? No. So the first thing I want to do is multiply everything through by what? 16. Yes, ma'am. So times 16, times 16, and times 16. Boom, goes away. So we got 16x plus y squared equals 16. So y squared is equal to what? Okay. Now, for number 14, you'll have to look at your identity sheet for this guy. So what is cosine 2 theta equal to? You might need to know where those are anyway, because isn't that one of the things I said you could use on your
Wait.
couple different things, right?
Yep. It's cosine squared minus sine squared. 1 minus 2 sine squared.
Or,
2 cosine squared.
okay, so let's do 2 cosine squared minus 1. You know why I'm going to do that? Because look, I got cosine here, don't I? So x is equal to 2 cosine squared theta minus 1. Now I got to solve for cosine squared, don't I? So how do I solve for cosine squared? Ooh, I don't even have to do that. Oh, this is going to be even easier. I'm going to take a shortcut, guys. You want a shortcut? Look what y is equal to. What would happen if we squared both sides of this? Y squared is equal to cosine squared, isn't it? Well, look at that. Cosine squared here, and we've got a cosine squared there, don't we? So what would happen if we took that and actually took this and plugged it in right there? We would get x equals 2 y squared minus 1, wouldn't we? Could we solve that for y squared? Yeah. We get 2y squared equals x plus 1, don't we? And then y squared is equal to 1/2. And that, I believe, is how we used to write the equation for a parabola. All right, guys, that's it for today. We are done a little early. So you've got time to either work on your review, which you need to be working on. Make sure you do well on your test on Wednesday. Okay? Or you can work on this homework and get it out of the way. Boom. Okay?